Day 4 of angles, congruent angles, and supplementary angles. We're getting into an actual geometric proof. This is what geometry is all about. A lot of you have probably heard, oh, I hate geometry because there's so many proofs in there. Maybe you haven't heard that, but hopefully a lot of you have heard, I love geometry because there's so many proofs in there. And that would be me. I love proofs. I gave you this example because this is the problem that I had you do in the video from yesterday. And I went over it in the video from yesterday, but it was real, not official. It wasn't real technical the way I had you write it out. I just wanted you to say angle 1 is congruent to angle 16 because they're both congruent to the same angle, and use transitive property. Like you might have said 1 was congruent to 9 because they're corresponding. You might have said 9 was congruent to 16 because they're alternate exterior. So since 1 and 16 are both congruent to 9, they must be congruent to each other. And that is perfectly sound, logical proof. That is awesome. That's what a proof is. It's just not written down in the technical way. This is the technical way. So let me explain it to you. First of all, it's called a two-column proof. We're going to prove this in 2 columns, and our 2 columns is a statement column and a reason column. So we're going to make some statement, and we're going to give the reason why that statement is true. Like I'm going to say, I don't have a lot of hair, and the reason is because it's true. All right, but it's going to be about this picture, not about me. Right, when you do a 2-column proof, you have a given and you have something that you're trying to prove. So the given is like your starting point. You're not just like handed nothing and said, make me a masterpiece out of that. You're given something. You're given some tools. You're given something, and I wrote a little arrow to the G. Usually given is just represented with the letter G. What you're trying to prove is represented with the letter P. So in this case, the given is that lines L is parallel to line M. That's these 2 lines right here, L and M, and A is parallel to B. Yes, that is a very sad looking B, but it is a B. So these 2 lines are parallel, these 2 lines are parallel. And like you wrote down the other day, if lines are parallel, then alternate interiors are equal, and alternate exteriors are equal, and correspondings are equal. So that's why you have to be given that information, so that we can say that alternate interiors are equal or whatever we want to use. Now, with this given information that these lines are parallel, we want to show that angle 1 is congruent to angle 13. So that's this angle and this angle. Well, they're both acute, so they most likely are going to be congruent, and it's going to be the same argument as yesterday as what I just went over now. We're going to use transitive property. We're going to try and find an angle up here or an angle over here that they're both congruent to, and therefore they're congruent to each other. But we're just going to write it down in a real technical fashion. So when it comes to technical fashion, the first statement and the last statement, you always know what those are. It's always the given and what you're trying to prove. So you can always start and end a proof pretty easily because they're all the same. I'm just going to scoot that up so we can start writing in our statements. So the first statement, statement number 1, you got to number them too. So statement number 1 is L is parallel to M and A is parallel to B. Reason, given to me. If it's given to you, it's true. So there you go. That's easy. The first line in a proof is always easy. Just copy down what the given says. Now we're going to build up to the fact that 1 is congruent to 13. So that's going to be the last thing we say. Okay, I'm done. 1 is congruent to 13. What is the reason? Transitive property. Remember, we're using transitive here. But we got to build up to that. Why? How did we use transitive? What's the angle that we use that they're both equal to? We got 4 choices. We could use 5, 8, 9, or 12. They're all, 1 and 13 are all congruent to each of those 4. So pick one. I always like the number 12. Let's do 12. Okay, so our first statement is going to be that 1 is congruent to 12. Well, it's technically our second statement because our first one is already there. Our third statement is going to be that 13 is congruent to 12. And then our fourth statement will be what we're trying to prove. 1 is congruent to 13 because of transitive property. So I'm going to skip to statement number 4. This is going to be a 4-line proof. And say that angle 1 is congruent to angle 13. And we know that we're going to use transitive property because we did this one yesterday, transitive property. So we just got to fill in the 2 missing statements and reasons, which is 1 is equal to an angle and 13 is equal to that same angle, and give the reasons why. So I'll start with 1. And what did I say I was going to use? 12. Angle 1 is congruent to angle 12. Why is that? Well, angle 1 and angle 12 are connected with this transversal. So if it's easier to see, you can cover up the bottom part. And what are angle 1 and 12 to each other? They're alternate exterior. Very good. Angle 1 and angle 12 are alternate exterior. So that's going to be the reason for statement number 2 is alternate exterior. Now we have to say that 13 is also congruent to 12, and then we can use transitive property. So why is angle 13 congruent to angle 12? Well, 13 and 12 are connected by this transversal, so we can cover up the left-hand side if it makes it easier to see. And what are 12 and 13? They are alternate interior angles. So our statement is true. 13 is congruent to 12 because, reason, they're alternate interior angles. So now that we have 1 and 13 both congruent to the same thing, 12, that's transitive property, people. They're both congruent to the same thing. They must be congruent to each other because of transitive property. We're done with our proof. Our first line was our given. Our last line was what we're trying to prove. And we gave a reason why that's true. And we have all these facts above it to back it up. That's what a proof is. You can't just write down 1 is congruent to 13 because of transitive property with nothing above it. I'll look at that and say, yeah, that might be true, but you didn't prove it to me. You didn't show me what 1 and 13 are both equal to. You got to show your facts. You got to build a case. All right. Let me show you what is a real common mistake here. People, well, let me do the next one. Here's another picture that we've been dealing with a lot. Just a regular old 2 parallel lines with a transversal. The given is, same thing, these lines are parallel. Now we want to prove that 3 is congruent to 7. 3 and 7, do those look familiar? They should. They're corresponding angles. They're both in the lower left-hand corner. So people want to make this a one-line proof. They want to say 3 is congruent to 7 because they're corresponding. No. The problem with that is we're trying to prove that 3 is congruent to 7. So we can't use that 3 is congruent to 7. All right, basically what I'm trying to say is whatever you're trying to prove, you can't use that as a reason. So we're essentially trying to prove that corresponding angles are congruent to each other. That's what this proof is. This is the proof of why corresponding angles are congruent to each other. So we can't just say corresponding angles are congruent to each other because we don't know that they are. We're trying to prove it. Once we prove it, then we can use it. But we haven't proved it yet. We're trying to prove it right now. So you can't just say 3 is congruent to 7 because of corresponding angles. Because that's what we're trying to prove. This is the proof for corresponding angles. That's going to take a while maybe to sink in for some people because that's a little bit tricky. That you can't use what you're trying to prove as a reason. You're never going to see corresponding angles over here as a reason. You cannot use them because that's what we're trying to prove. We're trying to prove that these 2 corresponding angles are equal to each other. So we can use everything else. We can use vertical, alternate interior, alternate exterior. We just can't use corresponding. All right, so what's the first statement? It's the given. So L is parallel to M. The reason is because it was given to me. So easy peasy. All right. This is another transitive proof. The very last statement that we are going to post is going to be angle 3 is congruent to angle 7, and our reason is going to be transitive. So it's the same strategy as the last one. We got to find another angle on here that both 3 and 7 are congruent to. Well, let's look at 3 and 7. They're obtuse. So let's pick another obtuse angle. We could pick 6, we could pick 2. There's two other ones. We could pick 6 or 2. It doesn't matter. I could prove it either using either one of those. Let's use 2. So I'm going to use 2. So transitive property, I'm going to try and show that both 7 and 3 are congruent to 2. So this is another 4-line proof. Second statement, I'm going to say angle 3 is congruent to angle 2. Is that true? If so, why? Is 3 congruent to 2? Is 2 true? Is it true? Can you say that? Yes, you can, but you can't just say because they're both obtuse and they look the same. You got to give me a reason. Remember that yesterday's video I gave you the 4 things that say that they're equal? One of them was vertical angles. Yes, 2 and 3 are vertical angles. So that's our reason why 2 and 3 are congruent, because they're vertical. All right, now we got to show 7 is congruent to 2, and then we have our transitive property. 3 and 7 both equal to the same thing. So is that true? Is 7 equal to 2? Is it true? That should be Dr. Seuss. All right, 7 is congruent to 2 because they're alternate exterior angles. Now remember, not just because they're alternate exterior doesn't mean they're congruent. They're only congruent if these lines are parallel. That's why it's so important to have that as a given. So yes, alternate exterior. Therefore, 3 and 7 are both equal to the same thing. In this case, angle 2. So they must be equal to each other because that's the definition of transitive property. So there you go, another proof for you, done and complete. And I've got one more, and then your day of watching my wonderful videos has come to completion. So here's our last proof, and you're gonna thank me for this one later. All right, the given in this one is angle 2 is congruent to angle 3. These two on the inside here, and we want to prove that 1 is congruent to 4. This one looks a little trickier. Well, what do we have here? We don't have parallel lines, so we don't have corresponding alternate interior, alternate exterior. All we have are crossing lines, so we do have vertical angles. So we have that 2 is congruent to 1 because those are vertical. We have that 3 is congruent to 4 because those are vertical. So we're trying to prove that 1 and 4 are congruent to each other. So since they're both congruent to equal things, 2 and 3, they must be congruent to each other, right? Right. Like you could think it through, you can see it. Since 2 and 3 equal each other, and 3 and 4 equal each other, and 1 and 2 equal each other, it's like a nice chain there. Everything's equal to each other. It's all equal. Now we just got to write it down in the proof, and I am going to not do that for you because, well, I guess I'll write some of it. But this, one of the problems in the book that I assigned for the due page today is this problem. So we're not going to meet tomorrow on Friday because it's asynchronous, but you're taking a test on Friday, so I'm not going to be able to go over this problem in the homework before you take the test, which I would really like to do. So that's kind of why I'm like giving you the answer to this homework problem almost, so that you do get a chance to see how it works. So you got to say the given. Angle 2 is congruent to angle 3. No surprises there. You always say the given first. Given, I'm just going to write a G for given. We're eventually trying to prove that 1 is congruent to 4. I'm just going to put that at the bottom. Oops, we don't know what the number is yet. I'm going to go ahead and say that's transitive because that's all I've really taught you so far is transitive. So what can 1 and 4 both be equal to? Therefore, they're equal to themselves. Well, you could pick either 1, 2, or 3, really. I'll just say 2 here. I'll say angle 1 is congruent to angle 2 because of vertical, and angle, this is my third statement, angle 3 is congruent to angle 4. That's also because of vertical. My handwriting is just getting sloppier by the second. Technically, you probably have to put another line in here, but that would be substitution, and I haven't really taught you substitution yet, so we're just going to skip that for now and say that's enough information. Technically, it's not, because you don't specifically have 4 and 1 equal to the same thing. You have 1 equal to 2, and you have 4 equal to 3. 2 and 3 are different things, but we do have that 2 and 3 are equal to each other. So it's close enough. It's like saying 4 is equal to something and 1 is equal to something, and those things are equal to each other, therefore 1 and 4 must be equal to each other. It's a little bit of a stretch to say transitive, but because of this, we're going to go ahead and just say it and challenge somebody to prove us wrong. So there you go. There's 3 proofs, all using transitive property, your introduction to proofs. Welcome to Honors Geometry. You're officially a high school honors student.